Or 7, Transformation of Quadratic Graphs. This is more graphing, more about quadratic formulas in general. The standard form of quadratic formula is this: y equals ax squared plus bx plus c. Quadratic term, linear term, constant term. What is vertex form? Vertex form is when you write like this: y equals a x minus h squared plus k. Where your vertex, inside opposite is h, outside follow is k. What we're going to do is we're going to go from, hey, how do you get it from this form to this form? And it's actually very simple. There's two ways to do it. Way 1, complete the square. That's what you guys all want to hear. Way 1 is you complete the square. If you complete the square on this, you're going to get it in vertex form. That's way 1. Way 2 is find the vertex. The way we find the vertex, nothing changes. X equals negative b over 2a. And once you get that, the way you plug it into the formula to get the y value. Your vertex is going to be negative b over 2a. The way you plug that into the function, we write this f of negative b over 2a. That just means plug it in. Once you have the vertex, that's your h and k right here. And then your a is the exact same a. That's two ways to go from standard form to vertex form. Way 1, complete the square. Way 2, find the vertex. And once you find the vertex, plug it in for h and k, and the a's match. It's that simple. Let's do that. Let's put these in vertex form real quick. And the whole point is I want to put it in this form. Now do it the way I think most people are going to do it, which is let's find the vertex. Like we did in section 1, x equals negative b over 2a. Will help me find the vertex. B is 4, negative 4, over a. A is the number in front, so a is 1. Keep that in mind. 2 times 1. I get negative 4 over 2, which is negative 2. My x value is negative 2, so that's going to go right here. If I want to find the y value of the vertex, my vertex right now is negative 2, and I want to find the y value. Plug that into the equation. Y equals negative 2 squared plus 4 times negative 2 plus 6. This is 4 plus negative 8 plus 6. 10 minus 8 is 2. Negative 2 and 2 is my vertex. This is my h and k. H is negative 2 and k is negative, and k is 2. And what's the a? The exact same a. A is 1. My equation's like this. Double negative makes a positive, and I get that right there. That's how I write it from standard form to vertex form. You just find the vertex, and that's your h and k, and then a is the same a. Another way to do it, just to show you, it's probably the only time I'm going to do it this way, you can also complete the square. Let me show you that way just for completeness. But if you want to complete the square, the way we complete the square, you want to get the x's by themselves. Let's subtract the 6 from both sides. Let's get y minus 6 equals x squared plus 4x. And then we're going to get the middle term divided by 2 and square it. 4 divided by 2 squared is 2 squared, which is 4. We're going to add 4 to both sides. Plus 4 plus 4. In that case, we get y minus 2 equals, remember, it's supposed to factor perfectly. X plus 2 squared is always the thing before you square it. And then, last thing I do is I move that over. You get this. So that's another way to do it. Either way you want to do it, I don't care which way. Either find the vertex or you complete the square. Both ways are proper. So let's do the next one just to make sure we got this. And I think find the vertex is a little easier. We'll do that. We want to put it in this form. And a should be easy. We have a down already. A is 2. That's going to be my 2. You just got to find h and k. Let's just find the vertex. We use the axis symmetry formula. X equals negative b over 2a to find the axis symmetry. Wash the double negatives. So I get 2 over 4, which is 3. The x of my vertex is 3. I'm trying to find the y value. You just plug it into the equation. Remember, we always do this first. That's 9. 9 times 2 is 18. Minus 36 plus 17. That's negative 16 plus 17. It's 1. My vertex is 3, 1. That's my h and that's my k. My equation is 2x minus 3 squared plus 1. That's how you put in vertex form. Just find the vertex, it's your h and k. It's like we've been doing since section 1, and then your a is the same a as right there. Let's go to this one real quick. I just want to see this one. Now look at this one. It's like an SAT question. You're just trying to match which one of these is that graph. First thing I want you to notice, it's opening down. I should notice a negative ax squared because it has a maximum. But anything that's not negative is out. These two are gone. And then, one way you could do this is you could plug in a point to see which one works. But also, just look at it. Do you think does that look like it got a little skinnier, this one, or did it get a little wider, this one? I would say it got wider. My answer is B. If it was negative 1/4, it would be like way like this. It would be a much skinnier graph. But it actually got wider than normal, so I'm going to use that. That's the idea. Okay, this one's interesting. We're going to go backwards. Instead of finding the equation, they give me the graph. They want me to find the equation. How do we do this? First, identify the vertex, because that is your h and k. If you point out what the vertex is, that gets your h and k. Right here, my vertex is this point right there. That's h and k. I'm actually almost halfway done. 4 and 3. All I want to do is find out what the a is. And how do I do that? Well, they give us another point on purpose. Use other point to find a. This is my other point. I'm going to let that be x and y. I'll plug that in here and here. That's to help me find my a. Then once I have that, I'm going to rewrite it all. Once you find your a and your x, h and k, rewrite it all. Find your vertex, that's your h and k. You want to find the a, use the other point as an x and y to plug it in. We're going to get this. 6 equals a, negative 3 plus 4, double negative, plus 3. This is an is. I see a lot of people put 4 right here. What's going on? That's an a, that's a number. You can't do that. Subtract 3 from both sides. A equals 3. The question wasn't what's a. The question was what's the equation. I got to rewrite this. Y equals 3x plus 4 squared plus 3. Notice how you always want to leave an x and y in the equation. You always have one of those. But you do want to fill in for h and k. That's how we do it. Let's do one more to practice. But that's the general idea of how you write an equation. Let me do that again. Y equals a x minus h squared plus k. Find my vertex right there. My vertex, that's my h and k. This is 3 and this is 0. We use the other point to help us find a. This is our x and our y. This will be 6 and this will be negative 6. Negative 6 equals a, 6 minus 3 squared plus 0. That's just going to be 3 squared. Negative 6 equals a times 9. You want to get a by itself, divide by 9. And a equals negative 2/3. Once you have that, I want the equation rewritten. We're going to plug it all in. It's going to be y equals the a value, which is negative 2/3, x minus 3 squared plus 0. That's going to go from graphs to writing an equation. Okay, next up, a little more review. Now we know what vertex form is. This is how we always graph. This is the inside x opposite. This is the outside. Outside is the y values to go up and down, you follow. A is the slope, the vertical stretch. If a is bigger than 1, it's a vertical stretch. If a is less than 1, greater than 0, it's a vertical shrink. All stuff we've been doing since chapter 2. The way we graph it's the exact same idea. Find the vertex first. We want to graph this really fast. Once you find the vertex, is it a vertical stretch or shrink? Is it opening up or down? Look at the first one here. Let's find the vertex. We're just going to do inside opposite, outside follow. My vertex is inside opposite, which is 3. Outside follow, negative 4. And you notice my a is 1. It's opening up. I'm going to graph this. I'm going to go 3, negative 4. And then it's opening up. If I want to make it a nice graph, I could find the y-intercept or the x-intercept. But it's just a little sketch. We're just doing a graph with transformations. The next one. Look at our vertex. There is no inside. X value is 0. Outside follow is 5. My a is negative 2. It's a vertical stretch with a flip. Right? The fact that it's negative means it's a vert flip. It's opening down. It's going to open down because of negative, and it's a vertical stretch of 2. So 1, 2, 1, 2, like this. So this right here, same idea. 1/2 x plus 6. Let's find the vertex. Inside opposite, outside follow. We get negative 6, negative 8. My a is 1/2. This is a vertical shrink. So if I was graphing this, we go negative 6, negative 8. Vertical shrink. We're just doing a sketch to help us gauge how big it should go. Something to that effect. If I want to make a nicer graph, I could find the y-intercept easily. Just plug in 0. I get 36, 18. I get, I think, 2. Hey, I'm not bad. It's probably a little higher, actually. But that's the idea. That's how you graph.